Hi, and welcome to the key lesson of Chapter 1. This is Lesson 2. This is Day 2 of Chapter 1. Feel free to stop this video at any time so you can work the problems through or just to think things over. All right, let's get going. Okay, we are doing the basics of describing data. We're talking about the center, spread, and summary statistics. I'll be going back and forth on my calculator as well up here. Okay, so I think you all know what the mean is. If you don't know what the mean is, that would be a little surprising at this point. That's simply adding all the numbers up and dividing by the total. The mean is called the balancing point because if you have a big or a small number, it slides toward that number to balance out all the other ones. It balances out the gap between the mean and the distant points. So it's often called the balancing point. The median is the middle number by count or by area. It's the middle number by count. So if you have 11 numbers, the sixth number is the middle number. No matter how big or small the outlier numbers are, it doesn't make any difference. It's the middle by count. This is often used in things like housing, where we want the median house price. The reason we want the median house price is because the guy that builds the mansion on the corner will skew the mean and make it artificially big, and it won't represent the houses. While the middle number in housing is often a better indicator of the center or typical house you have in a neighborhood, okay? All right, the mode is obviously the most common. This is often used maybe in shoe sizes. You're gonna have more size 8 shoes for men and maybe size 5 for women in your store because that's the most common one that you sell. It's still considered a measure of central tendency, although not as famous as the mean or the median. Okay, range is the max minus the minimum. That's not hard to understand. That's the most famous measure of spread. And the interquartile range, often called IQR, is the middle 50%. The reason this is used really commonly is because you often want to know what the middle is doing in a data set. Because sometimes the outliers on the high end and the low end will always be there no matter what. And so the range can change a lot, but it won't tell you what the middle is doing. Sometimes in educational data, we like to do things for the middle 50% and improve the middle 50%, assuming that the kids that are really solid academically and the kids that are weak academically will always be there. We often do things for the middle 50%. Okay, real quick, let's talk about resistant and non-resistant. As you notice, the mean is called non-resistant, meaning a giant number or a small number will drastically change the mean. It's not resistant to outliers. While the median is totally resistant. If you have a giant number or a small number, the middle number stays relatively the same, okay? And the mode is also considered resistant. The range is non-resistant. A giant number or a small number will drastically change it. While the IQR, I didn't write it, it is definitely resistant because the 25th percentile, which is Q1, and the 75th percentile, which is Q3, simply don't change very much, maybe not at all, if you add a high or a low number, okay? Now, the standard deviation is probably the second most famous statistic out there, behind the mean. The mean is the most famous, and the standard deviation is probably the second most famous. This procedure, you're going to want to probably stop the video and write this down, this whole procedure. I'm going to do this all for you later on in the lesson, but for right now, just go ahead and write this down, okay? The standard deviation means the typical distance from the mean. If you have 3 numbers that are exactly the same, 1, 1, and 1, those numbers don't deviate at all, and the standard deviation will be 0. If you have the numbers 1, 2, and 3, the mean is 2, and the standard deviation will be 1 because the numbers typically deviate from 2 by 1 unit. That is really easy to understand. The standard deviation is extremely intuitive. Like kids in a classroom, if I have kids that are ages 16 to 18 in the classroom, the standard deviation is going to be about 1. The typical age is 17, and they'll deviate from it by about 1. High schools will have a standard deviation total from freshmen to seniors of around 2 or 2.5 years. Okay? It's really intuitive. There's an easy calculation. This looks pretty wild, but it's nothing. The variance is the square of the standard deviation. It's not called standard deviation squared. It's suddenly called variance. Why is that? I mean, the explanation is long and isn't necessary. We really don't use variance that much in an AP Stats class. But you got to know the meaning of the word variance, because if it's used, you should know to square root it to get the standard deviation. Okay? And then the 5-number summary, this is off of a box plot, which you'll see later. But the 5-number summary that we do, you'll have, let's say you have a set of 1,000 numbers and it's too much to handle. Just give me the 5-number summary. That 5-number summary would be the minimum, the 25th percentile called Q1, the 50th percentile called the median, the 75th percentile called Q3, and the maximum number. Okay? And I have that all listed here. Percentile ranks, there's actually 3 accepted formulas for percentile. One is called the z-score, which we'll get to later in the chapter. The second one is how many numbers fall at or below that number. Okay? And the third one, which is the one we're going to use, is how many numbers fall below the data. Okay? So it's the z-score, which we're not covering here, at or below, or below. We're going to use below for this particular class. How many numbers fall below your data set? And we're going to practice all of this. So make sure that you got this thing, stop the video, make sure you got this all written down before we keep going. Okay, we're now going to find some of the simple things. We're going to find the mean, the standard deviation, and the range. I really don't think you're going to have any trouble finding the mean. Adding these up, dividing by the number of numbers, that's easy. I'm not even going to touch that. But I am going to show you how we got the standard deviation of 2.73 by hand, and then I'm going to show you how to do it on the calculator, okay? So by hand, what you do is you got to have the mean. So you're going to take every single number, 18, and you're going to subtract the mean. 24, subtract the mean. 17, subtract the mean. 21, subtract the mean. And 20, subtract the mean. Okay, that's the first step. Then you're going to get those numbers, -2, 4, -3, 1, and 0. I want you to notice one thing right away. These numbers always add to 0. The reason is the mean is the balancing point, which I said earlier. It balances the deviations from the mean out to 0. So what we're going to do is we're going to square them so we get an actual positive number, okay? And so we got 4, 16, 9, 1, and 0. And when we add those up, we get a sum of 30, as you can see right here. Then we're going to divide by n minus 1. There's 1, 2, 3, 4, 5 numbers. 5 numbers minus 1 is 4. And then we're going to square root it. And you're going to get this answer if you use your calculator. Now, there's 2 accepted forms of standard deviation. One is called S, which is what we're doing right here. S is the standard deviation of a statistic, assuming that these numbers are a sample of a larger population. If by chance these numbers are an entire population, you would actually divide by n, which would be 5, and that would be called sigma. And it would be a slightly different calculation. In AP statistics, we will use S about 95% of the time. Once in a while, we'll use sigma. The calculator will produce both answers because it doesn't know if you typed in a sample or a statistic. Okay, I'm now going to go over and I'm going to do these on the calculator, which is probably going to be how you do it, okay? Okay, so let me erase this. All right, so I'm going to bring up the calculator. Okay, so the first thing you do is you're going to type in the numbers. You're going to go stat edit and get to this list. And I'm going to type in 12, 9, 7, 11, 9, and 12. Okay. I'm going to go second, quit. Okay, get to the home screen. And then I'm going to go stat and arrow over to calculate. The very first one is one variable stats. I'm going to hit enter. And I'm going to tell it I want list 1, which is second and the 1 button. You'll see the small blue L1 down here. You may have a different calculator, so all you might have to do is click that and then hit enter or calculate. That's going to give you all kinds of statistics. It gives you the mean of 10. It gives you the standard deviation. This is S, if that's a population and you're dividing by N. And this one is dividing by N minus, I'm sorry, I got that backwards. This one is dividing by N minus 1, and this one is dividing by N. So sigma is dividing by N, S is dividing by N minus 1. This is the one we are most likely going to use almost every time. So that standard deviation is 2 on that, okay? All right. And then the final one here on C, as you can see, is you can go through the calculations yourself now that we've done that, okay? So let's scroll the screen up and get to the other ones. Okay, for D, E, and F, I know you know how to get the mean. That's no problem. Then we're going to get the 5-number summary. The 5-number summary is to take data and give us the minimum, the 25th percentile, the 50th percentile, the 75th percentile, and the max. That's what the 5-number summary does, okay? What you got to do first is put them in order, okay? And this can be done on your calculator very, very easily. So we're going to put them in order, and let's count the numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so the middle number is going to be the 5th number and the 6th number combined. When you have 2 middle numbers, the median will be the mean of the 2 middle numbers. As you can see, that comes out 5.5. Okay? Easy. Now, the 25th percentile will then be the middle of the numbers below the median. So since the median's right here at 5.5, there are 5 numbers below that. And the middle of those is one of the 4s. So one of the 4s is the 25th percentile. Then these numbers are the numbers above the median. There's 5 of them above 5.5. And you're going to find the middle number of those, which is that particular 7 right here. And that's going to be the 3rd quartile, or Q3, or the 75th percentile. And then the minimum and the maximum are 8 and 10. Okay. The range, obviously, that's easy to calculate. The range is obviously 6, 8 minus 2. And the IQR, which is the 75th minus the 25th, is 3. No problem at all. Now down here, if you can see this, I asked you for the percentile of 8. And I gave you earlier 3 ways to do the percentile range. Z-scores, which you don't know yet. Then at or below or below. I think I calculated how many are at or below. So I did at or below. So percentile of 8. 8 is how many numbers are at or below 8? All of them. 10 out of 10. It's called the 100th percentile, the max. Sometimes they'll call it the 99th. They don't usually go to 100. 2 is the lowest number. Well, how many numbers are at or below 2? 1 of the 10. So that'll be the 10th percentile. And then the 6, how many numbers are at or below 6? That would be 1, 2, 3, 4, 5, 6, 7. 7 of the 10 are at or below 6. That's the 70th percentile. Okay? Now, I'm going to go over to the calculator now, and I'm going to do this one. And I'm going to get the 5-number summary by using the calculator. This is probably how you're going to do this, okay? And you've seen this before. All right. Okay, so you go to Stat Edit, and I'm going to go Clear Enter to clear L1. I'm going to type these numbers in from item E. 9, enter. 10, enter. 6, enter. 10, enter. 11, enter. 14, enter. 11, enter. 9, enter. 9, enter. 8, enter. 14, enter. All right. Now, I'm just going to go second quit. If you want to sort them and do it by hand, this is not necessary, but you could. You could go stat, sort ascending. You could do this if you wanted to and say L1. Okay, if you wanted to sort them. And then if you go stat, enter, you'll see that they're all sorted. That actually is not necessary, but you could. Okay? So now that you know that. Stat, we're going to go calc, one variable stats for L1 again. It's already in there as my default, and I'm going to hit calculate. Now, you're going to use your down arrow to get this. So let's go through what these mean. This is X bar. X bar is the mean. Okay? This is the sum of all of the data. This is the sum of all of the data squared. You would never use that. This is S. This is the standard deviation of a sample, meaning you used n-1. This is the standard deviation if the data was a population, where we would only use n. Okay, and n is the number of samples. I will go down and voila, check this out. Minimum is 6. First quartile or the 25th percentile is 9. The median is 10. Q3 or the 75th percentile is 11. And the max is 14. And that is how you're going to do this. Probably via the calculator. Okay? All right, so as we return to this, I left my circle up there for you. I had all those answers there. I am very confident that you guys can do, let's see here. You guys can do the rest of these by yourself. Feel free to stop this if you need to so that you can write down the answers to this as you work through them by yourself. All right, here comes part 2 now. Now we're going to do all the displays for univariate data. Univariate means one, unicycle, etc., unicorn. Okay, so this is the dot plot. It's called a dot plot because we use dots. What's great about a dot plot is that you have all of the numbers. There's none of them missing. Okay, that's what's nice about a dot plot. And this is a sample of grades, where 90 to 100 is an A, the old traditional grading system, 80 to 89 is a B, there's a C, there's a D, and there's an F. Okay, there's your outlier, that's an F, okay? So, now, a histogram and a bar chart, or a bar graph, are the same thing. The reason they have different names, hear me on this, a histogram is called a histogram because it uses quantitative numbers. These are quantities. These are ranges, bin widths, or interval sizes. I use size 10 here, okay? A bar graph is for categorical data. And of course, your grades are a category. An A, a B, a C, a D, and an F are categories. So what I've done is I've basically done the same thing, except I categorized them, okay? So this is called a histogram, again, because it uses quantitative data. This is called a bar graph. It uses categorical data, okay? Now, this is the same display as this, except it's grouped by tens. The negative is that you lose the actual numbers. You don't have that. You can use dot plots for small pieces of data, but when you get really large pieces of data, there's no way you want to put 100,000 dots. You want to use histograms so you can categorize them, okay? All right, so this is a stem and leaf plot, and this is actually the exact same data as this. This is all the same data. And this stem and leaf plot, if you notice the stem and leaf plot, you kind of get some shape here. You get a little bit of a shape of a little bit of a bell-shaped or symmetric shaped curve, okay? This looks a little bit like it's skewed to the left. This looks a little more, this data looks a little more normally distributed, or like a bell-shaped curve. Sometimes different displays will show different shapes. It's just the nature of numbers, okay? And this is also the exact same data in a box plot. And this in a box plot also shows you get a little bit of a skewed left. Skewed left means that the tail is to the left, okay? Skewed left. And this means that this number probably pulled the mean toward it, meaning that skewed left is the mean is to the left of the median because of numbers like this that pull the mean toward it, because the mean is non-resistant to outliers, okay? You don't notice this being an outlier on this display, but you notice it here, you notice it here, and you notice it here and here, okay? But this is all the exact same data, which is kind of cool, okay? Okay, and there's a little bit more information on this. One of the great things about a stem and leaf plot is that it preserves the data, and the negative is it's not great for large sets of data, okay? This is great because it can handle, you can have a 5-number summary can summarize thousands of pieces of data. But what the negative of it is that you lose the individual data, if you want that, okay? So those are a few things there to get your notes all set up, okay? So again, feel free to stop this video at any time to get the notes. Okay, now we're going to go ahead and look at this data, okay? And this data is, we're going to do a stem and leaf plot off of this. So here are the numbers, okay? Here are the numbers. When you do a stem and leaf plot or a dot plot, it's kind of nice to start with a dot plot first, if you start with that. The reason is because when you do a dot plot first, you'll actually be organizing the data, because all you're doing is putting them in on a number line and stacking the ones that are the same. So that's easy. Once you get that, then it's really easy to do this second, the stem and leaf. And the reason it's so easy to do that second is because now you have a 49. I'm going to do intervals of 10. So 40s, 50s, 60s, and 70s. And you can easily divide that. 40s, there's your 50s, there's your 60s, there's your 70s, okay? And you can just stack them. And then you'll be able to put them in order. Obviously, 7-0 means 70. 7-4 means 74. And this you're simply going to type these numbers into L1 like you were shown earlier, and then you're going to go to one variable statistics, and you're going to simply produce that. The calculator does not have the ability to do a stem and leaf plot or a dot plot. You'd have to do that on your own. Okay? So that's pretty simple. Okay, now, looking at this, they want you to find some, in D&E, we want to use this to find the statistics that are asked. Okay, so here's your dot plot. In order to find the mean, you're just simply going to have to type these numbers into your calculator and do one variable stats. It's not going to be very hard to do. This one is a little trickier. You're going to have to type in 31 4 times to your calculator, 32 3 times, 33 1, 2, 3, 4, 5 times, etc. in order for you to get this. That's what's going to happen here. So this is a histogram, but the interval widths are only size 1, so it's pretty easy to figure out. Okay? Let's go to the last two down there. Okay, so for these last two, again, the 5-number summary, what I would do is I would type in 34, 36, 43, 50, 50, 52, etc. into L1 in my calculator. And then I would do one variable stats simply to get the 5-number summary. That's what I would do. And remember, the IQR is Q3 minus Q1. Okay? And again, on this one, you're not going to be able to get the mean. This is important. You cannot get the mean off a box plot. You just know, in this case, this looks a little bit skewed to the right. The mean is probably slightly to the right of the median. This is all done with medians. So you can't get the mean, you can't get the mode, but you can get the range. Okay? So on a box plot, the mean isn't possible to get, although you might know approximately where it is. Okay? And the 5-number summary, that's what it's built for. Just reading these minimum, Q1, median, Q3, and the maximum. Okay? All right, the final section we're doing is absolutely crucial. It is one of the most common questions on the AP test. It'll often say to describe a distribution. It'll often say compare distributions. When you get those questions, I got an acronym for you. It's called CUS. Okay? It's going to be, you're going to talk about the center, unusual features, shape, and spread. Okay? Okay, so here that is. Write this down. The center, you can talk about the mean with median or mode. Most people talk about the median and they use the symbol approximately. It's about something. They don't often really want you to get the exact number. They say something is about that. Unusual feature is gaps or outliers. Okay? Shape is, I'm going to get into shapes here. There are many different types of shapes, okay? And there are some that are really common. And then the spread. The spread is either the range, the IQR, or the standard deviation. Almost everyone does the range to communicate that. Now, if you were asked to compare distributions, two different distributions, you must use comparison words, such as the average height of the males is larger than the average height of the females. For the males, we had a 7-foot-tall person. He was an outlier. For the females, there were no outliers. The shape of the guys was skewed to the right because of that tall kid. And for the girls, it was approximately symmetric. And then the spread, the girls' range was between 5 foot and 5'9" or 9 inches, okay? While the guys was between 5'5" and 84 inches or 7 feet tall. We had a really tall kid, whatever that particular range is, subtracting out. That would be how you compare that. You got to use comparison words if you're going to do two different ones toward each other. Bigger, smaller, the same. That's important when you're going through this particular question that you get. It's a really common question. They'll say compare the distributions or describe this particular distribution that's just one, okay? Now, here's an example of gaps where you have some point here. Outliers, of course. This is an outlier to the high side. This is an outlier to the low side. Now, the shape. Shape. There are many common words for shape, okay? Normal is a real common one. You could also use bell-shaped. You can use bell-shaped. Symmetric, a lot of things are symmetric. That is symmetric. That is symmetric. But sometimes you have a distribution that just looks somewhat symmetric. Sometimes you have a box plot like this that's really balanced and you say, oh, the data looks symmetric, okay? This is called skewed left because there are smaller numbers to the left of the distribution and the tail is on the left. And once again, skewed left means that the mean is to the left of the median. Skewed right will be the opposite. An example of a skewed right distribution would be income in America. All the rich guys, Bill Gates and Warren Buffett and all those guys, they make so much money that they make the average person's salary look larger because they're an outlier. That's called skewed to the right because the mean is to the right of the median. Uniform is when there are no tails, when the endpoints of a distribution are just as common as the middle points. An example of this would be rolling a dice because a 1, a 2, a 3, a 4, a 5, and a 6 are all equally common. And so you have a uniform distribution. You could have this in a class of 40 kids where you have 8 Fs, 8 Ds, 8 Cs, 8 Bs, and 8 As, and it makes a perfect uniform distribution, although that's not very common. And then a unimodal distribution, this is unimodal, only has one mode. That's unimodal, one just has one peak. But a bimodal distribution is when you have two large areas, okay? And an example of this could be a school that serves a lot of wealthy kids and a lot of poor kids, and this is their income, where you have wealthy kids here and poor kids here, and there's no middle class at your school. There are schools like that in the county, okay? So the big four are normal, skewed right, skewed left, and uniform. Those are the big four that people usually talk about. And they'll use qualifiers like slightly skewed to the right, or barely skewed to the left, or approximately normal or symmetric. That's really common as well. All right, that is day 2 of chapter 1. Thank you.